We're going to look at dividing radical expressions, and the two things we're going to look at are really dividing and simplifying, and also rationalizing denominators. One of the first things to keep in mind with this is that when we have a division or a fraction underneath the square root symbol, we can split that fraction into two square roots. So the square root of the fraction a over b is the same as the square root of a divided by the square root of b. An example of that would be this first one, a, the square root of 36 over 81. We can split that into the square root of 36 divided by the square root of 81. Square root of 36 is 6, and then the square root of 81 is 9. So then that simplifies to 2 over 3. So this complicated square root radical expression simplifies nicely into the fraction 2/3. And that's why we like to be able to rewrite radical expressions, rationalize denominators, is sometimes they get something that's easier to work with and interpret. This also works when we're talking about cube roots or nth roots. So we can take this cube root and rewrite it as the cube root of 8 divided by the cube root of 125. When working with square roots, sometimes it's helpful to just kind of list your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. It's also helpful when working with cube roots to list your cubes. 1 squared, or 1 cubed, is 1 times 1 times 1, which is 1. 2 cubes, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 is 16. Times 4 again is 64. 5 times 5 is 25. Times 5 again is 125. And I'm going to stop there because those are the numbers I see. All right, so the cube root of 8 is 2. And the cube root of 125 is 5. So this complicated cube root simplifies nicely to 2 over 5. All right, the same would be true even if we're not dealing with just numbers here. So we've got the square root of 144 divided by the square root of c to the 4th. Square root of 144 is 12, and the square root of c to the 4th is c squared. So this complicated looking square root radical expression simplifies nicely to 12 over c squared. Keep going here. This one isn't going to maybe simplify quite as nicely as the other one. There might be something left under the square root, but still, we can split that square root, write it as the square root of 16 x to the 5th divided by the square root of y to the 8th. And then square root of 16 is 4. For square roots, we're looking for pairs. So in 5 x's, there are 2 pairs. So we can take out an x squared. When we take out an x squared, that was the same as x to the 4th on the inside, leaving one of those back on the inside. And then y to the 8th, we're looking for pairs. There would be 4 pairs, so that would be y to the 4th. So maybe it doesn't look as simplified as, say, 2/5 does, but we've removed the square root from at least the denominator. And that's really what we're looking at in this section down here, where we're rationalizing the denominator, removing square roots from there. All right, so sometimes it's actually helpful to rewrite the fraction of 2 square roots as a single square root or under a single radical, because it might help things simplify a little bit. So let's do that here. And really the first thing I see there is that we can cancel that factor of 1. And then 216 divided by 6, I'll just work that on the side. I don't have a calculator on hand. Well, would you look at that? Yeah. So 216 divided by 6 is 36. So that simplifies to the square root of 36. And well, the square root of 36 is 6. So this whole thing Simplified nicely to just the number 6. This also works if we're talking about fifth roots. So we could write this as the fifth root of 45 over 15. And 45 divided by 15 is 3. So the whole thing just simplifies not to 3, to the fifth root of 3. And again, with square roots, we would have this whole thing is just the square root, 34xy to the fifth over 2xy cubed. And then 34 over 2 is 17. X divided by x cancels. And y to the fifth divided by y cubed is y squared, which means we can simplify that a little bit more. 17, we can't do anything with that, but we have a pair of y's here, so let's pull that out. Y times the square root of 17. So this whole complicated thing simplifies to y times the square root of 17. All right, the next thing we're going to look at is rationalizing the denominator. And I know this was a topic from Algebra 2, so you've seen this before. It's kind of an old school thing, and it goes back to the days of dividing without calculators. So it is honestly a little bit outdated. But you'll see in high-stakes multiple choice tests often the denominator will be rationalized for answers, so it's still important to be able to recognize similarities between two ways of writing an expression. All right, so what we do is if we have a square root in the bottom, we're going to multiply by a factor of 1. I'm just going to multiply by square root of b over the square root of b, because you can always multiply by 1, and that's what this is, square root of b over square root of b. And in doing so, b square root of b times the square root of b is just b, and then a times the square root of b on the top. So we always just multiply by a factor of 1, multiplying by what it is that we see in the denominator, or the radical in the denominator. All right, so let's rewrite this as the square root of 18 divided by the square root of 5. So then we're going to multiply by the square root of 5 over the square root of 5, because that's just the number 1. Square root of 5 times the square root of 5 is 5. Square root of 18 times 5, you can put that under a single radical. That would be 90, right? 18 times 5, yep. And that'll reduce a little bit, because that is the same as the square root of 9 times the square root of 10 over 5. And the square root of 9 is 3, so 3 root 10 over 5. All right, so in this one, we don't need to multiply by 2 root 5. We just need to multiply by that root 5, because we don't want the radical. 2 is fine. So 15 root 3 over 2 root 5. We're going to multiply by root 5. I use the same example, I guess, root 5 and root 5. In doing so, root 5 times root 5 is going to be 5. So 2 times 5 is in the bottom. And then look at that, I have an Amazon package shipped. 15, and then that's going to be the square root of 15. And then, so we've got 15, root 15 over 10, but 15 over 10 will simplify a little bit. We can take a 5 out of each of those. And there we go. That's a little bit simpler looking. And last example here, we've got the square root of 5x over the square root of 30, just splitting that into two radicals, division of radicals. Multiply by the square root of 30 times the square root of 30. And on the bottom, we're going to get 30. And then 5 times 30 is 150. So 150, that should simplify. We should be able to take a 9 out of that. Actually, 25 would be better. Let's rewrite that as the square root of 25 times the square root of 25 times 6 would be 150. And then over 30, that would be square root of 25 is 5 times the square root of 6x over 30. And then 5 does go into 30. We'll We'll divide a 5 out of each of those. We've got 1 on the top. So square root of 6x. Ooh, that's ugly. Square root of 6x divided by 5. Nope, divided by 5. That should be a 6 there. Okay. All right, so two main ideas. Rationalizing the denominator, we do that by multiplying by whatever that radical is in the denominator over itself, because that's just the number 1. And then when we're dividing radicals, we can either split a radical of a fraction into a radical divided by a radical, or we can take that radical of a fraction, that radical divided by a radical, and turn it into a radical of a fraction, and that might help simplify things. All right, that is section 10.4.